Now here's something remarkable. If we put an NS magnet on a Dremel, north, red, south, blue, and we have a test magnet here on this scale, which you can see it's balanced, that's about 76 grams, and we put the Dremel up here, and then we spin lock the magnet with the Dremel, the weight's unchanged even though the magnet's being lifted up in the air and spinning. And if we remove the Dremel higher and higher, the magnet falls and the weight stays the same. We can make the test magnet even heavier like this, and you see it's balanced there, and so we put a cube magnet above it and get a spin lock. It's a magnetic attraction, but as we go away 5, 10, 15 millimeters, 60, 70, 100 millimeters away, you see the weight stays the same. It's still locked up there at 120 millimeters away. Still the full weight, 150, 200, still spinning and locked up there. And then when it drops, it's just the full weight of the magnet and the scale doesn't change. Now we've increased the weight of the magnet to about 40 grams, a very heavy thing. You can see it's balanced. We'll put the cube magnet over it and go to spin lock, like that. At close range you see the magnet's being pulled upward toward the cube magnet. As we go further away, the weight returns to normal. And as the cube magnets fall down slowly, you can see the weight's just as the same as having no Dremel there at all. Let's do that one more time. We're in spin lock, a very heavy magnet. The scale's being pulled upward by the attraction to the cube magnet. Go higher and higher. The magnets slowly start to fall down. All the way they're falling down, the weight's just as if the magnet's sitting at the bottom of the pole with no Dremel. Now if we turn this experiment around the other way, and we have a 10-gram magnet on a little pole, and we're going to lift it up with the Dremel rather than push it down, you can see there's a certain balanced weight on the pole. It's holding it up in the air. I want to take the Dremel further and further away so there's no support. It drops down to the ground, has exactly the same weight. Now what's happening here, the weight of a top is the same whether it's elevated and spinning or dead weight. So this is the dead weight, and that's an upside down top that's just spinning. So of course they have the same gravity. On the other hand, suppose we now flip the poles of that magnet so that it attracts the Dremel rather than repelling it. We lift it up, and now you can see the Dremel's lifting it up by about 10 grams. And that's just magnetic dipole attraction, nothing to do with the top. So as we go away, the weight returns to normal. And when we flip the poles of that magnet one more time so that it repels the Dremel magnet, we lift it up here, it's only being held by top-like attraction. Now you see it has a certain weight. As it falls, the weight doesn't change.